Regardless of where you grew up in the country, you've experienced weather. Your picnic has been disrupted by weather, your golf game, maybe your airline flight has been disrupted by weather. Thunderstorms, local intense snows, ice storms, heavy rains, flash floods. Those things occur all the time across the United States, and they do about $13 billion worth of damage to our economy every year. The thing about that type of weather is it's very difficult to predict it because it doesn't last for very long, and sometimes the onset is extremely rapid. So the societal impacts of what we call the high impact local weather are very substantial. And this project is really set out to try to create capabilities to predict that kind of weather in a new type of manner. Our project has enabled the capability of having all of the weather models, the observing systems, adapt to the weather as it's occurring so that the output of those forecasts is meaningful and useful to the people that are making decisions when and where the weather happens. Everything is driven by the weather. That's how the system works.
So contemporary weather forecasting is based on a model of computation of mainframe computers and batch scheduled jobs that did not respond in any dynamic way to the outside conditions. Cyber infrastructure is our collection of digital sensors, of networks, of computers, and of software that ties all of this together that we can now use to integrate the signals from the atmosphere directly into our simulations that generate the forecasts of the weather.
Cyber infrastructure is an essential software layer that sits between a scientist and the large-scale computational resources that they need. Scientists too often have been spending too much of their time dealing with computational, computing science aspects that, in a sense, slow down their science discovery. Cyber infrastructure is an effort to ease those tasks so that the scientists can focus on their science and do it more easily, but yet utilize large-scale computational resources, and all that complexity is absorbed in the cyber infrastructure layer.
Lead cyber infrastructure basically provides computational resources to maybe scientists and students who may not have it at their particular locations. It provides access to data. It provides access to services, which are basically tools which would be distributed at different organizations. But to an end user, they appear as a seamless tool that's residing on their desktop, and at all the additional support services that they need.
The power of LEED and cyber infrastructure in general is crossing the boundaries and the barriers that we've had to face for many years in education, and that is access to information and access to data, and also being able to interact with data. And this hasn't been possible to many students at the undergraduate level and even at the pre-college level. So that has become one of the most powerful components of LEED education.
The cyber infrastructure within LEED empowers the students by providing services and tools that allow them to go out and search data and run models that they prescribe, that they design. They design the experiment. A case in point would be a study of lake effect snows that my students are currently doing using the LEED infrastructure.
LEED is a tool of democratization. It essentially puts tools that has traditionally been only available at larger institutions and make those tools available to smaller institutions like minority serving institutions.
High impact local weather like thunderstorms, lake effect snows, floods, hurricanes is extremely disruptive to society. We lose a lot of lives in those types of storms. The economic hit is enormous, billions and billions of dollars a year. We think that with the adaptive cyber infrastructure capabilities LEED is developing, we'll be able to do a better job of forecasting, better job of warning, protecting life, saving property. We also will, we think, make the air transportation system much more efficient and effective, and we'll be able to really respond to the weather instead of being reactive to it. We'll actually be able to be proactive.
Cyber infrastructure is the foundation of modern science.
Cyber infrastructure is a means of diversifying the atmospheric sciences community.
Cyber infrastructure is training computer science graduate students to be tomorrow's knowledge workers.
Cyber infrastructure is an all-encompassing solution to problems and barriers traditionally faced in education and research.
Cyber infrastructure is access to vast amount of computational tools and resources for everyone in the science community.
Cyber infrastructure empowers students by providing a rich, authentic learning experience.
LEAD is an application of cyber infrastructure that has a chance to overturn traditional paradigms of predicting the weather and make our nation much more resilient and much more efficient in the face of very, very dangerous weather.
Cyber infrastructure.
Cyber infrastructure.
Cyber infrastructure.
Cyber infrastructure.
Cyber infrastructure.
Cyber infrastructure.
Cyber infrastructure.